Get start.
Good day, everyone. We are the group 2, and our topic is all about Ohm's law, voltage, current, and resistance.
When beginning to explore the world of electricity and electronics, it is vital to start by understanding the basic of voltage, current, and resistance. Voltage, current, and resistance, these are the three basic building blocks required to manipulate and utilize electricity. George Simon Ohm was a Bavarian scientist who studied electricity. Ohm starts by describing a unit of resistance that is defined by current and voltage. So, let's start with voltage and go from there.
Voltage. Volt is the measure of the push on each electron, which makes the electron move. The term potential difference and voltage are often used interchangeably to mean the push. Thus, you may see the term electromotive first, EMF, or just the word potential to describe the electron push. Letter E is used to symbolize voltage in writing electrical formulas, while letter V is more commonly used to abbreviate the unit of voltage on volts. So this is the voltic schematic symbols. Electron current. The flow of electron is given the name electron current, written I in formulas which means intensity. Ampere A is the unit of measure for current, named, of, named after André Ampere, an early pioneer in the study of electricity. Two conventions for current flow. These, these are two ways of looking at the current flow. One is the electron current flow, and the other is the conventional current flow. Conventional current assumes that current flows out of the positive side of the battery through the circuit and back to the negative side of the battery. Electron flow is what actually happens. The electrons flow out from the negative side of the battery through the circuit and back to the positive side of the battery. This is the two conventions for current flow, the electron flow and conventional current. Resistance. Simply stated, resistance, as its name implies, is the opposition to the current flow. It is a lot like friction. They both act to oppose motion and generate heat. The circuit element which does this perfectly is called the resistor. Resistance is a circuit element measured in ohms, Greek symbol omega, named after Simon Georg Ohm. This is the resistor schematic symbols.
Factors that determines resistance. Number 1. The material itself determines the resistance of a conductor. Silver is better conductor than copper, and copper is better than aluminum. The atomic structure plays the role of the resistance. There are some examples of symbols and their name and their specific resistance. Example number 1, Ag, which means silver. The specific resistance is 9.9. Example number 2, Cu, which means copper, and the specific resistance is 10.4. And example number 3, Au, which means gold, and specific resistance is 14.7, and etc. Number 2, cross-sectional area. The resistance is inversely proportional to the cross-sectional area. This means that if the cross-sectional area of the conductor is increased, its resistance will decrease. Number 3, length. The resistance is directly proportional to the length of a conductor. That is, a longer conductor has a greater resistance. Number 4, temperature. The temperature of material increases, the atoms in the material increase their activity, which cause the type of electrons to undergo more collisions and hence encounter more obstacles. In summary, voltage is the push that makes the current flow. while a resistance resists the current flow. So let's move on in statements of Ohm's law.
Statement of Ohm's law. Ohm's law, in its most basic of form, states that the amount of current, though the material varies directly with applied voltage and varies inversely with the resistance of the material. This means that a change in the voltage applied to a circuit will likewise cause the current flowing in the circuit to change. Doubling the voltage will also double the current. Halving the voltage will also halve the amount of current. On the other hand, resistance will also cause a change in current flow inversely. More voltage means increase in the circuit current, while more resistance means decrease in the current circuit. This linear relationship is often expressed in equation form.
So there are some examples of formulas that are given. E, which means voltage, I stands for current, and R stands for resistance. The formula of voltage is E is equal to I multiplied by R. The formula of current is I is equal to E divided by R. And the formula of resistance is R is equal to E divided by I.
Ohm's law and power. Power is the rate at which work is done or the rate at which heat is generated. The unit commonly used to specify electric power is the watt. An equation, you'll find power is abbreviated in the letter W. The power rating in the appliance indicates how fast it works, or the rate at which is generated heat. For example, a 60-watt electric drill can drill through a 2-inch board in about 10 seconds, but a 200-watt drill can do it much faster. Power Formula 1 is PIE. P stands for power, I stands for current, E stands for voltage. Power Formula 2, PIR. P stands for power, I squared stands for current, R stands for resistance. Power Formula 3, E squared stands for voltage, P stands for power, and R stands for resistance. These are the summary of the basic 12 formulas. Thank you.
I
That's
think
all,
that
Timothy.
again we are the group 2, and thank you for watching. Have a nice day.